In this video, we're going to do this example problem. It says, let f of xyz equal sine of xy minus 8 minus the natural log of z plus 1 plus 2x over y minus z. Part A says compute the gradient of f. Part B says find the equation of the tangent plane to the surface f of xyz, there should be a comma, equals 4 f420. And then part C says compute the directional derivative d sub u f of 420, where u is a unit vector in the direction of negative 2, 1, 0. Okay, so why don't you pause the video and try to solve the problem, and then I'll go over the answer. So part A says find the gradient, and to find the gradient we need f sub x, f sub y, and f sub z, right? So f sub x, the partial derivative with respect to x, I keep y and z constant and then take the derivative with respect to x. So when I do that, I'm going to get cosine of xy minus 8, but then I have to multiply by the derivative of the inside with respect to x, and I have an x times y, and I'm thinking of y as constant, so I have to multiply this by y. And then this ln of z plus 1, there's no x term, right? So it's just the constant with respect to x. So that's just, the derivative is going to be 0, okay? And then for the 2x over y minus z, I can think of that as 2 over y minus z times x. And I'm thinking of y and z as constants, so 2 over y minus z is a constant, right? And so I'm just going to get plus 2 over y minus z. Now I have to do f sub y, and for f sub y, I'm going to do the same thing. It's just cosine of xy minus 8, but then I have to multiply by the derivative of the inside, and that's going to give me x. And then again, I'm going to get 0 for the middle term, and then for the last term, I'm going to have a constant over y minus another constant. So for something like that, you can use, you could use the quotient rule, or you could write this as the constant 2x times y minus z to the negative 1 power, and then do the power rule, right? So when you do that, you're going to get negative 2x over y minus z in parentheses squared. Okay, so that's f sub y, and then f sub z is going to be, so this first term, this sine of xy minus 8, the derivative is going to be 0, right, because I don't have any z terms. For the middle one, I'm going to get negative 1 over z plus 1, and then I have to multiply by the derivative of the inside, but the derivative of the inside is just 1. And then for the last term, again, I have either a quotient rule, like I can rewrite this as 2x times y minus z to negative 1. And then when I do that, I'm going to get a plus 2x over y minus z squared. And the reason I have a plus instead of a minus is because I have this minus sign in front of the z. So when I do the chain rule, I have to multiply by negative 1. And then the negative 1 is going to cancel with the negative here, right? So then I'm going to get plus. Okay, so, we shouldn't write the answer as this. I mean, these are the 3 components, but we should write down the final answer like this. It's f sub x f sub y comma f sub z. Okay, that's the answer. for part A. And then for part B, it says find the equation of the tangent plane to the surface fxyz equals 4 at 4, 2, 0. So for something like this, okay, let's think about what the picture is. So when I have this function f of xyz, there's 3 independent variables, right? X, y, and z are independent variables. So you can't graph the function because you need 3 dimensions just for the domain, right? So one way to think about, to help visualize what's going on, one way I like to think about it is I like to think of this f of xyz as the temperature of the point xyz. So pretend that, if you have a point xyz in space, the temperature is given by this function. So you're looking at the points. See this surface, f of xyz equals 4. That means in terms of the temperature, it would be all the xyz points where the temperature is 4. So it's all the points where the temperature is 4. And what that's going to be is it's going to be some surface. I don't know, it's some surface. Okay, so maybe that's where the temperature is 4. And then you want to find the equation of the tangent plane to the surface at 4, 2, 0. So the point 4, 2, 0 is it's on this level surface, right? A level surface is the surface you get when you set f of xyz equal to a constant. So in this case, you're setting it equal to 4. So you're looking at the level surface when the constant is 4. And 4, 2, 0 is on this surface, right? It says the surface at 4, 2, 0. You're finding the equation of the tangent plane to the surface at 4, 2, 0. So 4, 2, 0 is on the level surface. I mean, that's implied in the problem. And you can actually check that this is true, because if you take 4, 2, 0, how do you tell if a point is on the surface? It's if f of xyz is equal to 4, right? So if you plug in 4, 2, 0 in for your xyz, you can in fact check that you're going to get f of 4, 2, 0 is 4. Anyway, you don't have to check that because the problem doesn't say you have to check it. But if they ask you to check it, that's what you would do. Okay, so what's going on in terms of the picture is, what tangent plane are they talking about? It's this tangent plane. So here's your surface, and you have this tangent plane, right? It's the plane that most closely matches the surface. It's the plane that's tangent to the surface. And then the theorem that you're supposed to remember is that the gradient is orthogonal. So this is the gradient evaluated at 4, 2, 0. It's orthogonal to the plane. So it sticks straight out of the plane. That's a fact from multivariable calculus. And then the idea is, well, how do you find the equation of this plane? If you know a normal vector and a point on the plane, you can find the equation of the plane. So what we need to do is we need to find the gradient at 4, 2, 0. We need to find what this vector is. And then that's going to be a normal vector to the surface. Well, that's where part A comes in, right? Because part A was to find the gradient. So we plug in 4, 2, 0 into the gradient, and we're going to get, okay, you have to plug in x equals 4, y equals 2, and z equals 0 into this. Okay, so you're going to get 2 times cosine of x times y is 8 minus 8, okay, plus 2 over y minus z. That's 2 over 2, right? Comma x, that's 2, cosine x times y, that's 8 minus 8, minus 2 times x, 2 times 4, over y minus z squared. So y minus z is 2 squared. And then comma, negative 1 over z plus 1, that's 0 plus 1 is 1, and then plus 2 times x is 8 over y minus z, that's 2 squared. Okay, let's simplify this. So this is going to be equal to, so the first term I have 2 times cosine a minus a. Well, a minus a is 0, right? Cosine of 0 is 1, so I get 2, and then plus 2 over 2. So that's 2 plus 1 is 3. And then I'm going to get 2 times cosine of 0, so that's 2, minus 8 over 4. So that's going to be 2 minus 2, which is 0. And then finally, I get negative 1 plus 8 over 4. Well, 8 over 4 is 2, so negative 1 plus 2 is 1. So my normal vector to the plane is 3, 0, 1. And now I know that the point is 4, 2, 0. So the equation of the plane is 3 times x minus 4 plus, okay, I don't even have to write that part down, plus 0 times parentheses y minus 2. Okay, but that's just going to be 0. And then plus 1 times, well, I guess I could just write the 1 down, times z minus 0. Well, okay, that simplifies a bit. Equals 0. So it's 3 times x minus 12 plus z equals 0. So that's 3x plus z equals 12. So depending on, how they want you to format the answer, either one could be correct. I mean, this one's probably the most simplified, right? I mean, if you look at the first one, it's not really, I mean, it's correct, but it's, z minus 0, it's kind of, I mean, I guess that's okay to leave it like this. Oh, did I do something wrong here? Okay. Oh, oops. I plugged in x equals 2 instead of 4. That should be a 4. Okay. So I get 4 minus 8 over 4. So that's 2, right? So there should be a 2. Oh, oops. Okay, so I get a plus 2 times... Okay, so I'll erase this part. So plus 2 times y minus 2 plus that equals 0. I'll just rewrite the whole thing. It's 3 times parentheses x minus 4 plus 2 times parentheses y minus 2 plus z equals 0. That's the equation of the plane. Okay, part C. Compute the directional derivative where u is a vector in the direction of negative 2, 1, 0. So negative 2, 1, 0 is not a unit vector. So let's figure out what the unit vector in the direction of negative 2, 1, 0 is. Well, to do that, you divide by the length, right? So I have the length of negative 2, 1, 0 is the square root of negative 2 squared plus 1 squared plus 0 squared. That's the square root of 5. And now I just divide by the length. So the unit vector is going to be negative 2 over root 5, 1 over root 5, 0 over root 5, that's just 0. So that's the unit vector they're talking about. And the question says compute the directional derivative of f in at 4, 2, 0 in the direction of u. Well, so let's just maybe just draw a picture to illustrate what's going on. So let's say that you are at the point 4, 2, 0, right? And you're heading in the direction. See, if you stay on this level surface, your temperature is going to stay at 4. And so your temperature wouldn't be changing. But so that's if you're moving along this the tangent plane instantaneously. If you move kind of a really, really short distance along the tangent plane, the rate of change will be 0 of temperature. But what is the rate of change of temperature if you're going in a different direction? So you're going in the direction of u. So let's say, I don't know, let's say u is this way. Well, the question is, how fast is the temperature changing when you're going in that direction? Well, that's what the question's asking. That's what the directional derivative tells you. It's the rate of change of the function in that direction. And then the theorem is that the answer is the dot product of the gradient with that unit vector. So the directional derivative is, that's d sub u of f at 4, 2, 0. It's the gradient of f at 4, 2, 0 dotted with u. And we found the gradient of f at 4, 2, 0. It's 3, 2, 1. So you just take the dot product of 3, 2, 1 with the vector u, and you're going to get negative 6 over root 5 plus 2 over root 5 plus 1 times 0, which is 0. And so I'm going to get negative 4 over root 5. So that's the answer. So what that means is, if I think about my f as the temperature at xyz, if my particle that I'm measuring the temperature of moves along the direction u, the temperature is going to decrease at a rate of negative 4 over root 5 per unit distance traveled. Okay, and that's the problem. And yep, that's how you do it. So that's all I have for this video. Thanks.